Welcome to this artificial intelligence module related recording. This module will form one part of the CS 160 course, and this particular recording will walk you through an example that uses an artificial intelligence / machine learning system to make predictions about the prices of homes in California. And your CS 160 instructor will get into details related to some of the concepts we'll be touching as part of this recording. But there are a couple of key ideas that I want you to keep in mind before we get going. So first, on your screen, you should be seeing an Excel spreadsheet that represents the housing data set that we'll be using as part of this recorded machine learning / artificial intelligence example. And our housing data set will be used by the machine learning system to create a paradigm that will allow it to predict the prices of homes in California. Now, our housing prices predictor will in particular be using an AI / machine learning process called supervised learning. In supervised learning, we feed data to our machine learning system in order to train it to identify patterns in the given data set that it can then use to make future predictions. Now, let me repeat this because it's a very, very important idea. In supervised learning, we feed data to our machine learning system. So in our scenario, we'll feed this data set to our machine learning system in order to train it so that it can identify patterns in this data that will allow it to make future predictions about home prices in California. Let's take a look at the housing data set that we'll be working with. I just took a sip of water. So what you're seeing here is the Excel spreadsheet that lays out the key features of the housing data set. So if you look at the first column here, it says longitude. The second column is latitude. What does that do? Well, these two features allow you to isolate the location of the house. So now I've already told you that the house is in California, but even if I had not, you could use the longitude / latitude values to identify the location of this particular house. Right? So the longitude and latitude features allow you to isolate the location of the house in this particular data point. And I think we have 20,600 odd data points in this particular housing data set. Okay, and then we have this housing median age column. And this is a feature that gives you the median age of the family living in the house, give the total rooms in the house. And this has to be divided by the total number of houses in this area to get the average number of rooms in individual houses. And the total bedrooms is another feature. So the 5 features that we looked at so far: longitude, latitude, housing median age, which means the median age of the family living in the house, the total rooms in the house, the total bedrooms in the house, the population of the area in which the house is located, the number of households living in this particular location, income of the family living in this particular house, and we'll have to scale it by 10,000 to get the median income in thousands of dollars. And then you have the median house value itself here in column I, that's another feature, and then the ocean proximity feature. Now, pause and think about what these features are telling us. So these features here: longitude, latitude, housing median age, the total number of rooms, the total number of bedrooms, the population of the area in which the house is located, the number of households in this area, the median income of the family living in the house, the ocean proximity. All of these features are useful in being able to predict the price of the house. And what's that value? What's the column that holds the price of a house? It's the median house value column. What you do next is you are going to load this housing data set, or any data set you're working with, into some Python program to better analyze information. So let me switch screens again and show you how you can load this Excel spreadsheet into Python. And go to a tool called Google Colab, and I will walk you through this code. Now, the good news is that you don't need to understand every specific instruction here, right? Increase the font for this Python code sample in a second. But before I do that, let me just repeat. So step one in the machine learning predictor building process is to just eyeball your data set. The data set that you're going to be working with, create your machine learning predictor, which we have done now. We looked at the housing data set. We have an understanding of the features that underpin the data set. And once you do that, step two is to use Python to better analyze the data set, create charts, try to find correlations between the features in the data set, etc. Okay, so we have step two now. Okay, let's look at this data set itself. The data set that we are working with is the housing data set that I shared with you earlier. And how do we get this data set into Python? Well, there's a Python function called read CSV. Remember, Excel file as an extension of CSV. And so when I say read CSV, I'm reading my Excel file into my Python program. And the read CSV function is part of the pandas package. So here when I say import pandas as PD, I'm importing a Python package that will allow me to work with data frames, and our Excel spreadsheet will be stored in these data frames. So right here, when I say housing equals pd.readcsv, this whole line here, all I'm doing, and don't worry about the code as yet, just focus on the conceptual idea. All I'm doing here is I'm uploading my housing data set into my Python program. If you keep going down this code here, there are a few things I want you to focus on. One is, with this correlation function, I'm trying to find the correlation between the different features in the housing data set. In particular, I'm trying to isolate any features that have an inordinate/large influence on the price of the house. Okay, so we are using the correlation function to find correlations between the features of the housing data set. Okay. Two, I'm creating the scatter plot. Now, these scatter plots are very useful in order to help me better understand what my data set actually represents. So the first step was just to eyeball the data set and get a sense of what the data set is all about. But eyeballing a data set has only limited effectiveness. So in this program, we'll use not just the correlation function, but also some scatter plots to better understand what the underlying housing data set is all about. So if I scroll down here, and we'll go to the code together in class, so don't worry about that as yet. But when you look at the output from running this code, there are a few things that should stand out. The first is all these values here are representing correlations between specific features of your housing data set. The one we really want to zero in on is this median income to median house value correlation. And see right here, the number is 0.688075. What that's telling you is that the median income of a family living in a house is a very, very strong predictor of the median house value, i.e. the price of the house. And there's a positive linear correlation, as you'll see in a second. But this number here is 68.8%. So the median house value, one way to read this number without getting too lost in technicalities, is to think of it as this number, 68.8%, is a way for us to weigh, and I'll spell that out, W-E-I-G-H, weigh the impact of the median income of the family living in the house on the median house value. And so 68.8% of the price of the house can be explained by the median income of the family living in the house. So it's a huge factor in predicting the price of a house, i.e. the median income of the family living in a house is a huge influence on the price of a house, which makes sense intuitively. If a family has a high median income, then typically they're living in a house which is pricier. But let's not just depend on our intuition. So once we have the output from the correlation function, and we can see that their median income has a inordinate impact on the median house value, we can start to look at charts to validate what the correlation function is telling us. Before we go to those charts that can validate what the correlation function is telling us, let's look at the output from a few of the scatter plot charts that we built in our program. So the first one was taking X and Y as a longitude and latitude and creating a scatter plot. And this gave us this scatter plot that I'm highlighting here. And as you can see here, these dots represent individual houses in our data set. And what's the shape look like? Well, this is Northern California. This is California on the US map. If you look at the US map as a whole, this shape here represents California. And then this chart here is the same chart as the one you saw before, except here you are using something called an alpha feature to find the hotspots where the number of houses are present at the highest levels. So the dark spots here indicate obviously that there are more houses in this location than let's say in these locations where the dots are lighter shaded or colored with a lighter shade. And that makes sense again, because if you look at California, this area here is Northern California, San Francisco Bay Area. This area here is Southern California, more LA and San Diego. And that's where the largest number of people live, and that's where the largest number of houses are located as well. So this chart helps us to better understand the density of population and houses in specific areas in California. Okay? And what does that tell you? When you think about it from a data analytics standpoint, it tells you that these areas are probably more pricier, i.e. have houses that are more expensive because of the dense population, or because there are more people living there, there are more houses there, these are population centers. And so typically you could envision these areas to have houses that are pricier than the more inland, the lighter shaded areas. Yeah. Now this chart here actually zeroes in on the population centers and the median house value. So as you can see here, this bar here is a heat map indicator. So it tells you as this color gets orange and then red and then dark red, the median house value is also going up. Now where are the darker shades on your chart here? Well, look at this here. In Northern California by the Bay, you have higher housing prices. Makes sense. Look at that. It's around the $500,000 mark for median house value. Same thing for San Diego and LA. And then houses that are inland are not so expensive, which again aligns with our intuition. So what is step 2 in the machine learning predictor building process doing for you? Well, it's ensuring that your intuitive understanding of the housing data set based on step 1, eyeballing the data, that intuitive understanding actually holds water. You are able to validate some of your initial intuitive assumptions by using charts and by using the correlation function. Yeah. And then here's where you have the scatter plots that plot each feature against the other. So the key part here is here. If you see here, this is the median house value on the y-axis. On the x-axis is the median income, and as the median income goes up, so does the median house value. Same thing if you come here, median income is on the y-axis as it's going up, and this is the median house value that's also going up, right? So the median house value and the median income are positively, linearly correlated. As one feature rises in value, so does the other. That's what this chart is telling you. And now that you know that from this particular chart, you can create a separate chart that just examines the relationship between the median income and the median house value. And that's what this chart is doing. As the median house value is going up, so does the median income, or vice versa. As the median income goes up, so does the median house value. Okay? So just to summarize, what we've seen so far in step 1 was you eyeballed the housing data set, right? You looked at this Excel spreadsheet and you tried to make an initial assessment of what this housing data set represents. What are the features? What are we trying to predict? What's the label? What are the values that we'll be using along with our label? And when I say label, it's the value that you're training your machine learning system to predict in the future. Step 1 is just to eyeball your raw data set. Step 2 is to then load your data set into Python and use some Python functions, such as the correlation function, and some Python charts, such as scatter plots, to better understand the relationships between the various features in your data set, to better